You've just been handed a project to design Wi-Fi for a brand new office. Now, this is the first time you're probably doing a Wi-Fi design and it's multi-story. So what do? You've never done it before, and now you want to know how you can do this in a timely fashion. The first thing is you need to do Wi-Fi design, right? And so maybe that requires training in order to understand how Wi-Fi works and how you can place APs on a floor plan. In this video, I'm going to go step by step into how I design a multi-story office. We'll go and use Hamina Planner to place APs on the floor plans, importing the floor plans, and coming up with a full design that you'll use to send to installers, and you'll understand how you're going to configure your access points and determine what signal will look like for this office space. So why don't we dive right into it with Hamina? All right, this is hamina.com. I'm going to start a brand new project here. We click on the top and scroll down to the bottom and click on new project. Now, when we start a new Wi-Fi design, or when I start a new Wi-Fi design, it always going to start off with the project name. So let's just call this the Wells New Offices. We're opening up a brand new office for the consulting firm, and it's going to be in the United States. We want to make sure our country is set properly, and our environment is going to be primarily an open office, and I'll leave it at the root folder. So I'll click save. From here, we're going to be presented with uploading the floor plans, and also optional to write notes. Now, before we get into the actual parameters of designing Wi-Fi for an office space, we will want to gather a lot of information prior to starting a design. I think a lot of people start off on the wrong foot when they just start placing APs out in the floor plan. And so we want to gather a lot of information prior to doing all of that. And so before I start gathering these requirements, I do want to give a shout out to our new sponsor, Meter. Thank you for sponsoring this video. And Meter is a place where you can go and get network equipment, full network stack of equipment, firewall, switches, APs, you name it. And it allows you to build a cloud managed network with full visibility into everything. And so if you go over to meter.com, you can also book a demo to check it out. So thank you to Meter for sponsoring this video. Now, when it comes to designing the office, a multi-floor office is quite a big project. So in order to come up with a good design, you will want to gather requirements from the people in this office. What are they going to do over Wi-Fi? How many devices are there going to be? What type of devices? What applications are they going to use? What are their requirements? How do they expect to use Wi-Fi? A lot of that you want to gather in the beginning before you start designing. So I would go and ask them a lot of questions. What areas are going to be important? What areas are people going to congregate in the office? That way you can plan for capacity as well. And so as we look into this office space, I will import 3 files. Because as we design for Wi-Fi in an office space, you want to be sure you have an accurate floor plan. And so in this floor plan, it needs to be fully accurate, not one drawn by crayon or by hand or in Excel. A floor plan that shows all the office spaces, all the furniture is also scaled as well. So I have 3 floor plans that I'm actually just going to drop into here. This can be a photo, an image. It could be SVG file, a PDF, or even a CAD file. And so Hamina will import that floor plan and start adding the different floors that I have available. So you can see at the top left up here, I have different floors. There is a 5th, 6th, and 7th floor. And so that's important to note as we design for multi-story. We want to align these floor plans for the accuracy of this build out. And so what I will do is start to build out a building. Once we have floor plans added into our project, we want to set a scale. And so setting a scale is important because that actually increases the accuracy of your design. If you don't have a proper scale, your predictive Wi-Fi design is going to be wildly inaccurate, and we don't want that because that'll affect really how your placement of your APs are going to be, the installation, and what you will ultimately see once APs are deployed. And so what we'll do is we'll take the scale on the left, click on scale, and I will pick a wall, and I will say let's just say that this from this left wall all the way to the right, which is a window, is about 90 feet. And so then I type in 90, I will set the scale, and now we have our scale for the sixth floor all set up. But now I'm dealing with a building, and I want all of these floor plans to be aligned, and the alignment will help us when it comes to seeing the propagation between floors. I don't know if you've been in an environment where you can actually see the signal of an AP on the floor above you or the floor below you. And in this model, we'll want to try to predict what that signal strength will look like coming from adjacent floors, the APs on the adjacent floors. So what I'll do is on the left side, I will head over to the multi-floor and raise floors tool, and I will click on align floors. Now over on the right side, we will get this align floors toolbar. And so this is over on the right pane. I will take the sixth or the fifth floor because when you import into or when you create a building, it'll start with the lowest floor first. Okay, so that is going to be my anchor, and I can click on, say, the this tool over here from the sixth floor. I'll look at the fifth floor. All right, so this is going to be our anchor point for aligning floors, and I will set the ceiling height. The ceiling height of this floor plan is going to be 15 feet. It's an open ceiling concept. In Hamina, there's this a measurement of what the attenuation is between between floors. For a lot of us, there's no way we could measure what that distance is between the fifth floor and the sixth floor. So instead, we want to measure what that attenuation will be. Because this is a brand new building, I don't know what that attenuation is like, but it's something that could be measured afterwards. Maybe it's 20 dB attenuation. So now I'm going to add the next floor that goes above the fifth. So there's the sixth floor. In the left side, you saw that it added a yellow outline there. And that's because now I could align this floor plan, the sixth floor, with the fifth floor plan. You could also change the scaling of what this looks like on the maps to try to make it align more accurately. And so here you can see that it's smaller, just a tad bit, and that's because I resized it. And so I will do my best to align each of these floors to the best I could, because it does affect the accuracy of the signal between floors. So I'm almost there. I think I've got it. These are nearly identical. I think that's slightly there. There you go. And what I was looking to do here when aligning floors is to try to grab a corner or look for an elevator, because elevators are going to be in the same spot on the same floors. So if the elevators and also the stairwells line up, then I think we're in a good spot. Now I'll take the seventh floor and drop that up on top there. And I could align that again using our anchor floor, which is the fifth floor. I will look for that elevator right here in the middle. Let me zoom in to try to show you how that alignment can look. So as I zoom in to that, you can see the yellow, which is the seventh floor, that I'm trying to align with the darker outline. That is the fifth floor. And so there I go, trying to align it. I know it's slightly off, so I will resize the floor plan to match. And I think we're pretty darn close here. There you go. That looks pretty good. So now we have the 5th, 6th, and 7th floor in this brand new building, right? So I took all the floor plans that were not in the building and I dragged them up here, starting with the lowest floor. Now that I have that aligned, I can head over to looking back at the floor plan. I'm looking at the 5th floor. When it comes to setting your design, you also want to define a requirement area. And we'll do this for every single floor that we deal with. A requirement area is going to be an area that is in scope for us. What is the area where Wi-Fi is needed? We can define areas that are out of scope, and those are areas that don't need Wi-Fi. Areas that don't need Wi-Fi could be areas that are maybe not in your tenant space. It could be a common shared hallway with other tenants in the building. And what I will do with this floor plan on the 5th floor is I will head over to this in out of scope zones on the very left side. Now the in and out of scope zones, that will tell Hamina where we want to focus our Wi-Fi design on. And so I will click on scope zones. This icon here next to scope zones to the right is showing that Hamina is auto detecting a scope zone. If I click on it, that blue outline shows, hey, you've got this scope zone. Is this acceptable? And I will take a look at it, make sure it is accurate. There is a courtyard here that it is not capturing, and maybe I could also include it or make it out of scope. But that is something that we could do. So I will, for now, accept it for this demo. And I've got everything that is out of scope kind of grayed out here. And even if I were to draw another scope zone, let's say this area down here on the stairwell is not covered, I can click and drag to highlight that and say out of scope, and you'll see that it grays out with the lines. Now we do that with every single floor. So I will go to the 6th floor. Here again, Hamina has already detected what that scope looks like. That's good. Even the 7th floor, it knows what the scopes are. Okay. So again, click on scope zone. I'll click accept. Go back to the 6th. It didn't bring that icon to me or wanted me to accept it. So now I've accepted the scope zones for this specific project. That's all 3 floors. And now those requirement areas are going to be where you're going to place your APs. And when somebody looks at a report or the installation report, they will know what is in scope. Now, the next part is now what takes sometimes the longest. The longest for me is drawing out walls. So I'll head over back to the 5th floor. And some people like to draw the walls themselves because they find that either relaxing, it's something that is pretty simple to do if you know what wall material you're dealing with. And what you would do is on the left side, click on walls, and you could start drawing out walls using the draw method on the right side. You select the type of wall material, and then you'll take the pen icon and start drawing those walls. Or you could use Hamina's auto draw, and it is detecting a bunch of drywalls, heavy types, and doors of the wooden type, both with a 5 dB attenuation. Hamina does a pretty good job here at selecting which is a wall, which is a door. There are elevators here, which aren't necessarily a dry wall, and I'll get to that in a moment. But I will accept this output of walls. And so I'll auto draw those walls. That saved me a lot of time on its own. Trust me. Sometimes drawing walls, especially for large projects, can get out of hand. You can see that we're also now looking at the 6th floor. I'm going to auto draw those walls. That looks pretty good to me. And the same will go for the 7th floor. I will auto draw those walls. And actually, now that I think about it, for the 7th floor, let's say the client told me that this area down here is not in scope. This is not their tenant space. I could go to the left, click on scope zones, and I will then just draw out the space. And you could use the command key. I'm using a Mac to reposition the line so that it is more accurate. And so I will highlight this whole area here, right click to indicate I'm done with drawing out the requirement area. And then I will say this is an out of scope zone. And that way it is not considered in your design. So we've drawn out the walls, but let's say if I go back to the 5th floor, let's say there was something that needs to be changed or modified, or the auto draw didn't do something completely accurate. So let's say that this wall right here is not a drywall. What if it's a concrete wall? Well, you could click on it. You could then delete that wall, or you can go into the right and select the correct wall material. So there you go. I've clicked on concrete and you can see that the color actually changed. So now that is a concrete wall, and that changes the attenuation of that concrete to concrete. The other thing is we have elevators. They're not walls, but they're an attenuation area. Those are things that I look at for every floor plan, and I really want to consider those in the design. On the left-hand side, where we looked at walls, there's also a separate drop down for the attenuation area. So I'll select attenuating objects, and then the right pane will show a list of all the different attenuating objects that you could select from. If you click on this icon over here, if I can drag my window there or zoom out a bit, I can create my own attenuating object based on maybe some materials that I've worked on in the past. But in this case, I will go to select elevator, and elevator will be an attenuating object that will define here where there's an actual elevator. So I'll click and drag to draw a rectangle and let go, and we've got an attenuating object there. We have another elevator here, and I think there is a third one. There is a freight elevator down here on near the corner. And so those are my attenuating objects. And you want to do that for every floor because typically those elevators are on the same locations on each floor. Actually, one down here. There you go. And this wall is incorrect. And I'll make that correction down here. You can see that there is a wall that goes right through the elevator. And in this case, we could actually click on walls, select drywall heavy, and draw out the wall that should go right here. I will check on the 5th floor that I missed that elevator. So I will select attenuating objects again. I'll scroll or zoom in so we can see this. And this one's not a straightforward object to draw out with a rectangle. So I will tap on my trackpad and then I will hold the command key to outline the shape of this rectangle. And we've got our elevator. I think I've got all of them, right? Who knew there were 4 elevators in this building? And then we'll go to the 7th floor. And I'm only concerned about this elevator here because it's in the area of in scope. And I will also capture this elevator over here, the freight elevator. The others we could probably draw out. So here's my thinking on this specific floor plan, because the tenant is occupying this space up here and over here on the side. But this space in gray is not theirs. Okay. If we look at the scope zones, it's out of scope. But that doesn't mean that signal from an AP that could be in this area could possibly make it to this area just through all this material. It's possible, but it may not. And so that's why it may be important to actually draw out the attenuating objects, even in the areas that are not in scope. That way, you get a more realistic viewpoint of what signal may look like. So we'll draw that out. And so there you go. We've drawn out the walls. We've drawn out attenuating objects for the elevators. We've removed some areas that are not in scope. There's one thing that is important when looking at floor plans is understanding what some of these icons could be. So in this open office space, there are these circles here, dark circles. And I'm curious as to what those could be. This is where you would have to talk to the architect or the building manager, or if the building exists and it's just plain open and with no walls yet, you could walk the space to understand what these could be. And this could be supporting columns, like cement columns. And if that's the case, then you would have to draw out the object for that. And so you could either use an existing object of what that could be, or maybe create a new one. Let's say I'm going to add a custom type. Maybe it is a cement build, whatever that may be. And you give that an attenuation, and we can let's make it stand out a bit. We'll make it blue. That way you could draw this out. Now, drawing out a perfect circle is actually pretty hard. So you'll hold down the command key on a Mac to draw the best circle you could draw. But let's say now I've got dozens of these. I'll just copy and paste. But you guys get what I'm saying about drawing each of these objects. So take the time to make the floor plan as accurate as possible with the attenuating objects and the walls, so that your predictive can be as accurate as well. The next step in the design is to create a capacity area. Now, Wi-Fi is going to be affected by how many devices are joined to an AP and what application they are using. In Hamina, you can draw out capacity zones. And if you click on the left under capacity zones and click on capacity, it'll open up the right pane where you can write down your capacity zone name. And in this case, I will call it, fifth floor open desks. And let's say there's 60 iPhones and 60 MacBooks. And then I will take the capacity zone and draw it out here in the middle. This is just an example. I'm drawing out this specific area as a capacity zone. And then I'll right click, and now we've got our capacity zone here. This window here just popped up because it's now going to tell us, once we start placing APs, how many radios we have, how many clients per radio, and what our limit is. Now, the limits can be modified right here, the max number of client devices per radio. What I'd like to see from Hamina is how to determine capacity zones with applications as well, because this is showing us associated clients to a radio. But I think understanding how many clients would be using a specific application could tie into this. We could draw out other areas as well. So if I click here and draw out another capacity zone, I can draw that. If I click near the edge, I can then, let me click on the edit button, click here near the edge. Then I can rename this. Maybe it's fifth floor open desks north. And here there's not as many desks compared to the bottom area down here. We've got 5 areas. So let's just say maybe it's 30 iPhones. Oh, I pressed a shortcut key. 30 iPhones and 30 Macs. So now I've defined a capacity zone up here on this floor plan. If I click on this capacity zone, you can see it still has a name of fifth floor open desks with a number of devices. And you can do that with every single floor. This will make it more accurate in terms of whether or not you're meeting your capacity area, your capacity for your design. Because coverage is one thing, we also want to design for capacity. All right, so we've got our walls, we've scaled the floor plan, we have our in scope and out of scope areas, we have our attenuating objects, we've got a capacity zone. I will start to declutter what I see on this screen. And so I will remove things like or what's visible, the attenuating objects and the walls, just so now I can see what the floor plan looks like and where I'll start to place APs. There are a couple of things that I like to check. If we look, and I like to just drop that opacity down a little bit, just so I can see below the heat map color. We also want to know what our defined client height is, and this could be where you're at a seated level. It could be that you're designing for a different type of environment, and maybe that environment's got robots, and those robots are closer to the ground, maybe less than a foot off the ground, and that's where the Wi-Fi adapter is, like in a warehouse space, and that's where the client Wi-Fi adapter is. So you would change that client height. So you want to be aware of of how your clients are going to be on the Wi-Fi network, so you can better understand your requirements that you put into the design. And so here we'll also enable this feature of full building propagation. I want to try this out. It's in beta. And now I will start placing APs. And again, I want to thank Meter for sponsoring this video. Meter is creating a wonderful product where you have a full network stack that you can manage in the cloud. It's got a great interface. You're able to get your ISP through their interface as well, because I know I've had a challenge getting ISPs once I'm staging up a brand new network. That's something you could do as part of your Wi-Fi design. And then you could fully automate your deployment and use Meter command to even build your networks, to build dashboards. You don't need separate servers or programming experience to do that. So go ahead, visit meter.com, go book a demo and check it out for yourself. So in this design, I'm actually going to go and use a Meter access point. I will select Meter from the access point drop-down list. And the way that I got there is on the left-hand side. I hovered over access points, clicked on access points. I could have Hamina Planner just auto plan the APs for me, but I like to selectively place APs where I want them. And so once I select an access point, I'm going to then select the model. And what's nice about Hamina is you could actually see what the propagation pattern would look like for a specific access point. And I have this MW08 here in my lab environment. And this is what the propagation pattern looks like for this AP if we were to ceiling mount it. Now, if we were to wall mount it, it would look very different, something like this. And you can see the datasheet gain, what it looks like for the given band. And I think that's such a useful feature if you're trying to understand what it means when you select an access point, because every access point has a slightly different propagation pattern. Then I'm going to select what kind of mounting type I'm going to use. In this scenario, I'm always using a ceiling mount of deployment for an open office space. And usually I want to keep it to around the height of the light fixtures. And so if our ceiling is about 15 feet, it's an open office. Let's just say our APs are going to be mounted at about 15 feet. If I click on show more, I could work on developing a standard naming convention. I can also set the default transmit power. Because I design to capacity, I like to pick a specific transmit power range. And usually higher density AP deployments for me, that means m- changing that transmit power to be around 10 dBm or even less, lower, maybe about 8 dBm. And so in this case, for the design, we're going to select 8 dBm for 5 gigahertz. And for 6 gigahertz, I do want clients to pick 5 gigahertz overall. And so I will lower this to probably 3 dBm. We could have Hamina Planner do the channel assignment for us automatically, or we can look at all the channel settings and tell it, disable unnecessary interfering 2.4 gigahertz radios, or switch 2.4 radios to 5 if they have dual 5 gig capability. For 5 gigahertz, we can say, what channel widths are we allowing? For me, it's usually starting at the highest possible and only if it's possible. You want to start off with a channel width that'll work and then go lower if you're getting too much channel interference. And here we can say, hey, let's do 40 and then we only allow one AP channel interference. And then you can select which channels you want to have allowed in the auto channel planner. And then the same goes for 6 gigahertz. So I will save there. So now I'm ready to start putting APs. And the way I typically lay out APs is I try to understand where some of the VIPs are. If there's a VIP office or a boardroom type of office, then that's typically where I'm going to place an access point first. And so in this scenario, I have a super large boardroom right here. And I will go ahead and place an access point right here. So now I placed a meter access point. This is giving our propagation on 5 gigahertz. And again, I can expand this down here and look at global settings. And if I don't like the opacity here, because I can't see underneath the floor plan, I can change that opacity. This is our legend down below. As I hover over a specific area, that's going to tell us what that signal strength looks like in the predictive. And as I start to lay out APs, I want to also make sure I don't have them laid out too closely. When you're trying to meet certain capacity requirements, you tend to put APs a lot closer together, but then that's when I start going for directional antennas as an example. And so again, here I'll probably place one right around here in the open office space, but look at what happens when it's right here and you've got an office here in the corner. Now, when people head over there to that office space, they will have signal drop to about negative 70, maybe as low as 71. And that's when you start trying to think about how you want to have these APs deployed in on your floor plan. And so we can keep going here and place another AP, say down here to cover these open desks. I just know that all of these people connected to this AP will probably not meet the capacity requirements. And as you can see with this number, let me zoom in because this AP has a couple of different numbers that it's displaying. If I can zoom in some more, this will probably help you out. This AP has a 2.4 and a 5 gigahertz radio operating on these channels, respectively. And the bottom number is how many devices are going to be joining that radio. So on the 2.4 gigahertz radio, channel 11, we have 18 devices that are joining that radio. But on channel 149 and 5 gigahertz, there's 104 devices that will be joining to this radio. And we can see what those are. The reason why it's red and green is if we look at these limits down here on the bottom, because we are saying we want to keep the limit to 40 devices under the 5 gigahertz radio. Now, if you wanted to change that, you could say, we allow 150, and then you could see that it turns green. But obviously, we don't want to keep too many devices to that radio because we won't meet the capacity requirements. And so the way we'll look at that, again, see there's now 153 clients that could join to any 5 gigahertz radio. And that means we'll need to add more access points. And so as I start looking at this specific area, because there's so many different desks and a lot of people joining here, we need to place 2 access points. And it's possible that we need one in this lounge area as well. So as you can see, the heat map is starting to look better, but we still have areas of concern. And this area up here is going to be an area of concern for capacity. So we could add another access point there. We could add one here in this office. I don't know what this is, this future stair area. I'm not sure what that's going to be like. But we do have restrooms down here in this corner, and that might be something worth having signal there because of safety reasons. You don't want someone to fall and not be able to make a call out if there's no cell signal, but that's going to be dependent on the requirements for your business. So we could add an AP down here instead by those offices, and then we have to cover these offices down here as well, and maybe one over here for roaming. All right, so now we're going to go to the next floor just so I can show you what it would look like knowing there are APs on adjacent floors. So the 6th floor now shows you that there's an AP above, or actually below us on the 5th floor. That's what that little indicator looks like. And if I went to the 7th floor, we don't see any because we're not seeing that prediction make it to the 7th floor. If I started to take an AP and placed it here on this map, we can see that you've got good signal strength. Let's go back to the 6th floor and we'll see what that icon looks like. Right here, there's an AP in this area above us, right over here, and actually right here, and an AP below us. And so that's what's important about seeing the signal as it starts to bleed between floors. All right, heading back to the 5th floor, I want to talk about your primary and secondary coverage. Primary coverage is the signal strength that everyone always looks for. They want to have 100% coverage throughout the floor plan. And when you don't have that, then you need to address what those issues are. And in these areas, we have, say, this bathroom here that doesn't have any signal, probably due to the wall material. So we could fix that by placing one there or one right there. And then we have an area over here that doesn't have any signal. Looks like a small little meeting space for 2 people. We could place an access point here to cover that. And then there's a bathroom here that also doesn't have any signal. We could maybe move the AP here to try to get better signal. Now we're about negative 66. And then there's the elevators that don't have signal. So primary coverage this is what we're looking at. If I look at the heat map, I have coverage primary selected. What I like to do, especially with Hamina Planner, is to use something called the client view. That's this client experience person right here on the left side. We click on client view and we pretend that we're a client that maybe came out of this elevator. So I'll click and drag and we can see which access point they are joining to based on where they are on the floor plan. And let's say this person decides to walk this way, walks over here to a different conference room is what they're going to, as a meeting they're attending. And as they walk through the door, based on the type of client that we're dealing with, because I have selected on the right side, which is an iPhone, we are looking at what its capabilities are. And Hamina is telling you what that client experience would look like given your design. Because iPhones and Apple devices tend to be a little bit more sticky, right where I have this person at, it's saying from its AP connected to over here, it's negative 64 dBm. It's probably not going to change to another access point. And so that's why when you have APs that are too close to each other, you don't want that because the device won't select the nearest AP. The next thing that I will look at is secondary coverage. Down below on the bottom left, we'll go to the secondary coverage heat map. And secondary coverage is good for knowing what signal would look like for surrounding APs. So if this AP down here went down, what would that secondary coverage look like from the surrounding APs? So for redundancy purposes, maybe you want to have additional secondary coverage, but that just means you may have to place another AP to try to meet secondary coverage requirements. But just keep in mind that having too many APs in a given area, you will have challenges roaming because the signal strength will look really strong for every single AP that you're near. So for example, in between these two APs, I'm still at negative 59 trying to join to, as I'm joining to this AP, but maybe I want to join to this one instead. And so that's not going to happen until I reach that threshold that Apple has to start looking for a new AP. All right, the other heat maps that we look at is channel interference. That's one that I like to look at because as you design for your devices and you want stability, and maybe you have a certain number of APs deployed, you also want to provide maybe higher bandwidth. But you can only do that if you're able to do that. And here I'm looking at the channel interference heat map, and everything shows that it's looking clean. And that's because the APs are down, let's see at what configuration they're at. 40 megahertz is what we're looking at right now. But if I can see that based right here. But if I wanted to say go all the way up to 80 or even 160, and I don't want to do 20 and 40. If I save that, the channel interference heat map starts to look a lot different because we're wanting to allow at least one AP on the same two APs on the same channel. Then we start to see that it's not as clean. It's kind of clean, but you can see this AP and this AP both operating on channel 149 at 80 megahertz wide. And so they are operating on the same channel. There's channel overlap. We might not be able to meet our capacity requirements, and therefore our speed will be slower. And these heat maps will change depending on how much allowed interference you want. If you set it to none, it starts to look a lot worse. If I say I want only 160 megahertz wide channels, then we're going to really start having problems. And that's why when you design, you want to have these requirements up front. You want to be able to describe to the end users why certain channel widths are important to have this ability and to also have that reliability when you are under load. So I tend to go with a 20 megahertz channel width, especially in a city with a lot of neighboring access points, a lot of neighboring Wi-Fi networks, and also when you're deploying a lot of APs. Now, let's say you've gotten to the point where you're at a good spot. You have all the access points that you need for your deployment. Your Wi-Fi design is looking good. You've even had someone spot check it for you. Now, the next step is to order access points. But how do you know how many access points you need? You can count them all manually, or you can start counting each one per floor. But the other thing you could do is also create a bill of materials list. So within Hamina at the top right, up here, there is a little notepad, and we can click on bill of materials, and that would show us how many Wi-Fi access points. There's a total of 14, what the vendor and model is, how many are ceiling mount or how many are wall mount. And this is pretty fluid application. So if I clicked on this access point and said, it's not a wall mount. I mean, it's not a ceiling mount. It's a wall mount, maybe on this wall right here. This indicator is the direction the AP is facing. So I'm going to say it's actually on this wall on the right, and it's facing in this direction. So if I look at the bill of materials again, now we see there is still 14 access points, but one of them is now a wall mount access point versus a ceiling access point. But let's say you need to create a report for your client or an end user or for your installer, you could go up to that little notepad again and just create a brand new report. It'll open it in a new tab. I'm going to show the simulation, which is my predictive design. My AP that I selected is only 2.4 and 5 gigahertz. And then, we'll call this the Packet 6 offices, and then hit create. Now, this is the report that I can work with for the end user or for the installer, for the client, and I can opt to select different pages that I want displayed to the end user. So I want to show building materials. I want to show project notes. Maybe there's some notes that we need to put into there. We want to show any notes that might be on the floor plan or any of the zones. So we can show that. And then we go down to AP placement. They can click on each one and also see their characteristics. But on the right side, if I clicked on an AP, we can see the characteristics of that individual AP. Choose to show more information, and that's the kind of information you could put into this report. Then we can look at signal coverage, secondary coverage, maybe tertiary coverage is not really something that we look at, so we can opt to hide that. So that's what our secondary coverage looks like. The tertiary won't be there. SNR and all the other heat maps that you want to view. My favorite's the client view. That way, if it's an end user, they can simulate how someone would come into an office and what that signal would look like for a client that they select from the drop-down list. And then if required, BLE and also switching and cabling, which I didn't get into. And that's how I'll generally work with other people, whether it's the stakeholders, the IT managers, or an installer. I will show this to them, and then we could share that out through this link up here. And so here's sharing the report. Give it a password so that way only those with the password can see it, or you can just completely disable the password and then generate the link. And so if you have any questions, let me know in the comments if you found that useful, going through my thought process, a step-by-step of using Hamina to try to build a multi-story Wi-Fi design and a workflow that helps to come to an end result that matches what you designed. Then you would do the on-site validation.